2022-2023 set number 1, question number 3. So the question state, consider the molecule of water H2O and methane CH4 and draw the Lewis structure. So for first question, they ask us to draw a Lewis structure. I use this method to draw a Lewis structure. First, we calculate for the valence electron and draw. So we will draw the compound for H2O first. So we calculate the valence electron and we get 8 valence electron. So as we know, one pairs, or I can state that one bonding pairs consists 2 electron because they share. So here we can state that 2 plus 2, here also 2, it consists of 4 valence electron. So another 4 valence electron will be 1 lone pair and another 1 lone pair. So for compound CH4, also we get for the valence electron is 8 valence electron. And when we draw, we know the bonding pairs consist 2 electron because they share. So here is 2 electron, 2 electron, and 2 electron, and 2 electron. So the total up is 8 electron. And why the compound doesn't have lone pairs? Because they are already equal to the valence electron. So we go to the next question. It states that the electron pair arrangement for both molecules are tetrahedral. However, the bond angle of H2O of water is smaller than methane. Give explanation based on Vesper. So we need to know, based on the Lewis structure, we know here the angle will be less than 120 and here it will be 109.5 degree. Okay, why? In H2O molecule, it has 2 lone pairs and 2 bonding pairs. Repulsion at lone pair, lone pair, lone pair, lone pair. Repulsion for H2O because it consists 2 lone pair. Therefore, in CH4 molecule, it has 4 bonding pairs. So for the repulsion is bonding pair, and it will be equal because it doesn't have any lone pairs. So the angle for CH4 is 109.5 degree. So the angle for H2O, it will be less than CH4 or less than 120 because the repulsion lone pair is greater than lone pair, bonding pair. So take a note, lone pair, repulsion is greater than lone pair, and bonding pair. So for the third question, it asks us to state the geometry of both molecules. So for H2O, the molecular shape is a V shape, and the class is AB2, E2, and CH4 molecular shape is tetrahedral, and for the class is AB4. Why AB2, E2? Because E is for lone pair. And why the class for CH4 is AB4? Because it doesn't consist of any lone pairs in the Lewis structure. And we go to the next question. So for next question, it states that both carbon dioxide CO2 molecule and diamond involve covalent bonding in their atomic arrangement. However, solid CO2 exhibit lower melting point compared to diamond. Explain the observation. So the question is asked to explain why the CO2 solid has a lower melting point compared to diamond. Because they are in the question already state both of CO2 and diamond is involved in the covalent bonding. But why CO2 solid is the melting point is lower than diamond? So here the answer. CO2 is the molecular covalent solid in which holding by weak van der Waals forces. And weak van der Waals forces need less energy to break the bond. And diamond is a giant covalent solid which holding by strong covalent bond. So strong covalent bond needs more energy to break the bond. So the sentence that I underline is the sentence that you need to add in your answer. So you can need for this question you just need to state the forces and less energy or more energy for break the bond. That's all for me. Thank you.